Welcome back to Algebra 1C 8.2 notes, multiplying radicals. So we're going to start with our steps. So our steps here are just to multiply the coefficients. So if you don't remember what a coefficient is, that's the stuff outside of the variable, or in this case, outside of the radical. And we're going to multiply our radicands, which is the stuff inside the radical. So we'll multiply our inside stuff together, we'll multiply our outside stuff together, and then if needed, we'll be able to simplify that radical just like we did in the 8.1 notes. So you can always review that video if you have any questions about simplifying radicals, but we'll do that process together here too. So if I look at our first example, because that's really it for the actual process, right? Our first example here, we have 2 radical 2 times 3 radical 5. So what we need to remember is that even within 2 radical 2, this really means 2 times radical 2 times 3 times radical 5. So I could write these all together with multiplication dots in between if I wanted to. So I could write 2 times radical 2 times 3 times radical 5. Which then allows me to kind of multiply stuff in any order. So I can do 2 times 3, our outside stuff, is 6. And then radical 2 times radical 5 is radical 10. So now if I remember my list of perfect squares, right, so things like radical 4, radical 9, radical 16, radical 25, etc., right? 10 is going to be bigger than 9 and 4, so I could divide by 9. That's not going to work. 4 is not going to go into 10 evenly. So essentially what I have here is something that I cannot simplify. So that is my final answer, 6 radical 10. For number B, we have 3 radical 6 times negative radical 3. So if I want to write this out, I might think of this as 3 times radical 6 times negative 1 times radical 3. So when it comes time for me to multiply my coefficients together, 3 times negative 1 is just going to be negative 3. And then 6 times, or radical 6 times radical 3 is radical 18. But if I think of my list of perfect squares, radical 18 is actually a multiple of radical 9, right? So I could write this as radical 9 times radical 2. Radical 9 is, of course, regular 3. And then I can multiply my outside stuff together again. So negative 3 times 3 is negative 9. 2 is still inside the radical. So my final simplified answer is negative 9 radical 2. So again, multiply the outside stuff together, inside stuff together, and then simplify if needed. So that one did require simplification. Moving on to example C, we have on the outside 4 times 2 is 8. And on the inside here, before I go too far, I've got radical 3 times radical 4, but what do we know about radical 4? I know that that's actually a perfect square, right? So I'm actually going to write that as a 2. So I'm actually going to rewrite this whole thing here. So we have 4 times radical 3 times 2, right? That radical 4 became just a regular 2. Now when I multiply my outside stuff together, 4 times 2 is 8 times 2 is 16, and then my radical 3 stays on the inside. So sometimes we'll have the option of simplifying even before we multiply stuff together, which could just make our life a little easier, right? We could have multiplied together and then simplified. That also would have worked and would have resulted in the same answer. But this was a much quicker and easier, in my opinion, way to get to that same answer. All right, moving on to example D. Again, we have a negative outside our first radical here. So I'm just going to think negative times 4, right? So negative 1 times 4 is negative 4. And then for my radical parts, I have radical 7 times radical 6. So that's going to be 7 times 6. I'm going to check my old calculator here because it doesn't hurt. 42. Well, is 42 going to be a product of a perfect square? I know it's a product of 7 and 6. So do I have any possibilities there? Do I have any repeating numbers with 7 and 6? No, this is not a perfect square because 7, 2, and 3 each show up one time. In a perfect square, we would need a factor to show up 2 times. So I cannot simplify radical 42. So we're just going to keep it as is. So even though it's a bigger number than we're used to seeing, it doesn't always mean it simplifies. 18 did simplify, but 42 doesn't because it doesn't have a perfect square factor. Okay, for our next one here, we have 2 radical 5 to the second power. So this is where we have to remember, what does this mean? This is squaring, right? Which means multiply by itself. So in this case, that's applying to parentheses. So everything in these parentheses, this 2 radical 5, is going to be multiplied by another copy of 2 radical 5. So again, outside stuff multiplies together, and then inside stuff multiplies together. But when I see radical 5 times radical 5, right, that means I have 2 copies of the same thing. So I could think radical 25, right? But I could also just say to myself, well, radical 5 times radical 5 is going to give me a regular 5. Same way that the square root of 25 would give me a regular 5. So my final answer here will be 20. And we're going to see that again in this next one over here, because we have the square root of 1,738 squared. So when I have 1,738 square root times the square root of 1,738, I don't need to reach for my calculator because I know this has to be a perfect square because it's squared. So it's always going to be a perfect square if we square it. That's how we find a perfect square, right? So I can just kind of eliminate that step and just write what's inside the radical. So whenever we have 2 copies of the same number, it's just going to make 1 copy outside of our radical. All right, let's do some more practice here. We just got plenty of examples here to practice on. So we have 9 times 2. But what do we have here? This is a perfect square, right? I can see this on my chart, so I know it's a perfect square. So I'm going to rewrite this before I start multiplying stuff together. The square root of 9 is regular 3. So now outside I have 9 times 2 times 3. So 9 times, I'm going to do 2 times 3 is 6, times 9 is 54, times radical 2. And then I know I don't have to simplify radical 2, which is nice. On example H over here, again, we have some stuff outside of our radicals. So we've got negative 5 times negative 2 is going to make positive 10. And then I have radical 6 times radical 3 is radical 18. So 18, I'm going to check all of my numbers above 18. So I'm going to look at 16, is not going to go into 18. 9 will. How many times will 9 go into 18? So 9 goes into 18 twice. So we can write this as radical 9 times radical 2. Radical 9 is, of course, equal to 3, right? Square root of 9 is equal to 3. So I'm going to replace that with a 3. And then again, right, these are both outside numbers, so I need to multiply them together. So 3 times 10 is 30, and we get 30 radical 2. Moving on to I, we have 3 radical 6 times 2 radical 6. So again, outside stuff together, 3 times 2 is 6. And then we have radical 6 times radical 6. So as we were talking about in the last page, I could multiply those together and get 36, and then look at my chart to see that it is in fact a perfect square. But I should also know that 6 times 6 is definitely going to make a perfect square, right? So the square root of 6 squared is going to give me just 6. So these guys are going to just become regular old 6 outside of a radical. 2 copies inside of a radical makes 1 copy outside. And then 6 times 6 is 36, regular 36. And we'll see something similar happen with J over here. We have negative radical 2 times negative radical 2. So I know that a negative times a negative is a positive. And I know that radical 2 times radical 2 is regular 2. right? So my answer here is just 2. You could also have multiplied this together and gotten radical 4, which also simplifies to 2. So one way isn't necessarily better. We're going to get the same result, but some ways might be faster than others. And the more we understand this, the easier it's going to be. All right, next example. We got, I think, 2 examples left here. Yep. All right, so we got negative 8 times 5, right? I'm going to start there. So negative 8 times 5 is negative 40. And then radical 3 times radical 5 is going to be radical 15. So if I'm going to do my job here, right, I'm going to check all the numbers smaller than 15. So is 15 divisible by 9, 4, and 1 we're not going to check, right? 1's not going to help us out. So is it divisible by 9 or 4? No. So we're just going to leave it as radical 15. So negative 40 radical 15. Sometimes it's just as easy as multiplying stuff together, and we're done. And our last example here, same idea, right? 3 times 7 is 21. 7 times 3 is also 21, but that part is inside of a radical. And we're going to check all the numbers above 21 or smaller than 21. So is 21 divisible by 16? Is it divisible by 9? Is it divisible by 4? No to all of these, right? So 21, radical 21 is our answer. Thanks for joining me.